Okay, so for today's class, we're going to talk about Factorial ANOVA. So this is a new unit. So we're going to deal with more and more complicated issues. So in the past, we talked about one-way ANOVA, comparing groups, 2, 3, 4, on one dependent variable and just one IV. And so Factorial ANOVA, the difference is that now we have more than one IV. Before we only had one IV. For example, when we talked about like stats exams, we talked about the IV being using textbook A or textbook B. So that we're just comparing differences on that. And so, for example, Factorial ANOVA, we introduced another IV. So in addition to two different textbooks, textbook A, textbook B, we also have separate the class or participants into beginning level or advanced students, like students who've taken only 2 or less classes versus students who've taken more than 2 classes, just for example. And so there's 2 different IVs, and then we're going to look at how they compare on the outcome variable stats exam results. So one thing that you'll often hear me talk about is 2 by 2, 2 by 3s. So the 2 by 2 is the level or the number of groups in each of the independent variable. So for example, in this first IV, there's 2 different stats books. So there's 2 levels, second IV, 2 levels. So it's 2 by 2. So also the 2 by 2, it will give you a sense, if you multiply them together, it'll give you a sense of how many cells there are when you combine the 2 variables, 2 IVs. So here are some characteristics of Factorial ANOVA. One is different cases assigned to different combination levels of IVs. Okay, so in other words, I wouldn't assign a person in both textbook A and textbook B. So they're assigned to different IVs, similar to the thing we talked about in one-way ANOVA. So different people are in different IVs. In each case, each participant is only measured once. And all levels of IVs are fixed. We decide them ahead of time. And Factorial fully crossed means that there's cases receive all possible combinations of IVs. And there are participants in each of all the cells. So in terms of research questions, in Factorial ANOVA, we will be dealing with 3 types of research questions. So one type is the main effect of the IVs. And this question asks, are there mean differences among the levels of this IV? And so for example, the stats example, one question is, are the mean score differences between those who use textbook A versus those who use textbook B? That's one main effect question. And the other main effect question is, are test scores different across those who have taken more stats courses than those with less, comparing advanced to beginning level of stats students? So we'll have 2 types, like for that example, 2 main effects. And the main effects are simply the one-way ANOVAs, right? They're just looking at it separately, so looking at it 2 times. And then we have an interaction effect. So that's the question that we're answering is, does the pattern of means for one IV change at different levels of another IV? Okay, so what it means is that, okay, is textbook A is better than textbook B. Does that differ across those who have taken more stats courses versus less? Or is it consistent across both conditions, both situations? So that's an interaction effect. And I don't know if you talked about interaction in regression. No, okay. But I bet you talked about moderation, right? Moderation effect.
Moderator variable.
Okay, moderator. So moderator is actually interaction. So it's the same concept, same statistical concept interaction. So this is a moderation effect. I'll give you more examples and we'll talk about them later on. And then the last question is, if there is an interaction, what are the specifics of the interaction? If a mean difference is found, what is the source of it, and how does it interact between the two variables? So let's go back to this textbook competency example. So the main effects, one is, do students using textbook A have significantly different stat scores than those using textbook B? So one-way ANOVA, main effect. And the interaction effect question is, does the advantage of using textbook A over textbook B hold across students with different levels of stats competencies? And so if I was going to put it in a graph form, figure form, it would look like table form. It would look like this. This is the first variable, which textbook is used. And the second IV is whether students are at beginning with fewer stats courses prior or advanced with more stats courses. And as I mentioned, we have cells 2 by 2, so 4 cells. First cell is those that are more advanced and using textbook A. Cell 2 is those that are advanced and using textbook B. And cell 3 is those beginning students using textbook A. And then fourth cell is beginning students using textbook B. So 4 different cells. So if the results look like this is made up stuff. So let's see how we might interpret this. So the first thing is, if the outcome variable is stat scores, and then we're gonna look at textbook. So textbook is our main IV. And let's not look at this yet. So if we look at all students together, so those who use textbook A scored 93. Those who use textbook B scored 85. Okay, so do you think textbook A is better or not?
Probably.
Yeah, probably, yeah. So probably is a good answer because I didn't give you F values or P values. So it looks, eyeballing, it looks like there's significant difference, but don't know. Okay, so later, so we answer this is a main effect. Okay, and then we look at interaction. And so for example, if I found an interaction effect that was significant F, significant P, and then I would go and look at, break it down and look at how is it different, how is it interacting. And so based on these two, so we would separate it by the more advanced students and the newer beginning students. And the more advanced students, those that use textbook A would have a 96. Those that use textbook B have a 95. Let's assume that's not significant. So what we would say is that, okay, despite that overall there's a main effect, however, it depends on the level of competency of students, how many stats courses they've taken in the past. And those that have taken more stats courses in the past, regardless of using which textbook, their scores are roughly the same. Okay. However, for those that are at a beginning level that haven't taken much stats course in the past, those that use textbook A had significantly higher scores than those that use textbook B, one having 90 and one having 75. So that's an interaction effect. So in like layman terms, I would add a depends. Whether textbook A is better than textbook B depends on what type of students that are using textbooks. If it's those that are more at a beginning stage, there is an effect of using textbook A resulting in higher scores, but if they have already taken a lot of classes before, it doesn't matter. So that depends is the interaction, and it's like the moderation that you talked about in regression. Making sense so far? Okay. So I'm going to use another example to illustrate, and this will be example of perfectionists and using intervention. So let's say this personalized feedback intervention is a type of intervention that could be tested in terms of dealing with perfectionists. So how this works is that you get feedback on your perfectionistic level. So perfectionists, they tend to have extremely high standards, or they can't accept anything imperfect. But they think they need to achieve to that point. But if you let them know that actually you're being too perfectionistic, no one else is cares about all these details, or is that much striving or bothered by imperfection like you. You're in the 99 percentile. Maybe that could change people who have perfectionism. They come to a realization that, okay, this is not normal. I'm setting too high of a standard. I need to adjust. So this is what this personalized feedback intervention aims to do. So let's say our research question is we want to see if personalized feedback intervention is effective in treating perfectionists who have depressive mood. So what we do is we will assign people to different conditions. One is those that get the intervention and those that are control group. And then we will compare their post-intervention scores and see if those that are in the intervention group have lower depressive mood scores than those in the control group. If so, then it's a sign or it supports that the intervention works. So that's sort of like how the study is designed. However, we want to see if there's an interaction effect. Is the effectiveness of a personalized feedback intervention on depressive mood the same across different types of perfectionists? Let's say, based on your homework, you were introduced that there's adaptive perfectionist, maladaptive perfectionist, and non-perfectionist. So does it work equally for those three different types? So using the table, we would have a 2x3 cells. So here we have the control group intervention. And here we have the other IV, which is the three different types of perfectionists. And so the first cell is those that are in the control group that are adaptive perfectionists. And this next cell is those that are maladaptive perfectionists assigned to the control group, and the non-perfectionists assigned to the control group. And similarly, on the intervention column, there's adaptive, maladaptive, and non-perfectionists. Okay, so if this was the results of intervention and perfectionists, this is depressive mood. So here are the people in the control group. They're depressive mood scores. And here are those in the intervention group. They're post-depressive mood scores. And these are for adaptives, maladaptives, and non-perfectionists. And this is lines indicating their scores. So these are not change scores. These are all post. So these are different people. So based on this, how would you interpret this? Let's say there's an interaction effect. First question, let's say there's an interaction effect. So does personalized feedback work the same across different types of perfectionists? No, it doesn't, right? And so how so, would you say?
I'm a little bit colorblind, but I'm assuming that's maladaptive is the downward line,
Yes.
right? Yeah. So then maladaptive is more responsive to intervention.
Yes. So it seems to work for maladaptives, but not so much adaptives and non-perfectionists. Yeah, exactly. And so why did I make up something that maladaptives would, intervention would be more effective for maladaptives? Any thoughts about how we might explain this? Okay, so I'll give you my explanation. So there's different types of perfectionists. I don't know if I talked about this yet or not. No, right? Okay, so perfectionism is a multidimensional construct thing. And so there's positive, good aspects of perfectionism. that is, you have a strong striving, perfectionistic striving. You want to achieve as best as you can, and you set very high standards. So that's good. Sometimes we're not sure if that's good or not, but research has indicated that's associated with self-esteem, associated with achievement. It's not much related to anxiety and depression. So setting good standards, want to achieve perfection, that in itself is good. But there's another dimension of perfectionism, which using the almost perfect scale we call discrepancy. So discrepancy is, in other words, it's gap. So gap between your ideal perfectionistic standards and where you think you're at. So people with high discrepancy, they always focus on their imperfection, like where they lack perfection, and always feel like they're never good enough. So that's someone with high discrepancy. So for example, if someone got a 99 points on the test, they focus on that 1 point, and they can't let go of that because that's imperfect. Or if someone's giving a speech and there's 100 people so engaged and there's one person that's sleeping, and then they focus on that negative aspect. So that's discrepancies and maladaptive ones. So adaptive perfectionists are those that have high standards, but they don't have high discrepancy. They strive to be excellent, but they don't dwell on their mistakes or the imperfection. And maladaptives are high on both, high standards, high discrepancy, and then non-perfectionists are those that are low on all of those dimensions. Okay, so why did I make up numbers that look like this? So this study, hypothetically, is for a group of perfectionists who are depressed. So we give them this intervention to help them be aware of their perfectionism and see if it lowers that discrepancy. And so for maladaptive perfectionists, those that have that receive the intervention, they're able to cope better or adapt better from their perfectionistic tendencies, which were linked to their depression. So then, in turn, their depressive scores are not as high. However, those that are adaptive or non-perfectionists, but are also depressed, their depression is not related to their perfectionism. So if you deal with the perfection, it doesn't help. Their depression probably related to other factors. So when you compare the adaptives and non-perfectionists across intervention versus control group, then their scores are not going to differ much. But if you compare the maladaptives, which the depression is, the perfectionism, the maladaptive perfectionism is the source of their depression, then they're going to have lower depression scores. So that's sort of the background of how I made up this hypothetical results. So this is another example of interaction. Okay, so interaction is a form of moderation. It is moderation. And then I don't know if you heard of the term mediation. And sometimes it's so confusing to me. And I think it took many, many years that I can intuitively tell you if it's a moderation or a mediation when I hear a research question or explain it. Before I would let me look up my textbook or let me Google and then figure it out. So I thought I would spend 3 minutes explaining ways that help me differentiate the two. So one is the first one. So both are explaining relationships between predictor and criterion. So a predictor and an outcome variable. So for example, this was textbook and stat scores, or intervention and depressive mood scores. And so the moderation is that it changes, this variable changes the direction or the strength of effect between these two variables. So that's the interaction effect that we talked about. So what type of perfectionist you are makes a difference. So whether this intervention has an effect on depressive mood, it depends on the type of perfectionist you are. So it depends. So when does it work, or whom does it work for? So this is the type of research questions that moderation answers. However, mediation answers another type of question. So predictor and criterion. And it answers how and why. Why does this predictor predict this outcome variable? Why does it happen? How does it happen? What kind of factors are associated with it? So using the example that we did, so let's say receiving an intervention improves the depressive mood. And the mediator would be that it changes one's cognitive appraisal of themselves, or helps them realize that they were like outliers out of the norm compared to others, and then so they sort of changed their beliefs or dealt with irrational beliefs. So this is the variable that explains the relationship from how this relates to that. And so another example would be like textbook A is better in terms of getting good stats grades, is because it provides more, it uses a lot of graph or visual effects to explain things. And so that makes it easier to comprehend. So that would be a mediator variable. What mediates the relationship between this and that? So this is moderator, this is mediator. Make sense? Yeah, hopefully after a while, if you need it, it'll stick more in terms of the difference between the two. Okay, so I've explained a lot about interaction, about factorial designs. Next, I'm going to talk about assumptions. And this is going to be very similar to the assumptions that we've done based on one-way ANOVA. So the only difference is that the assumption guidelines now apply to each cell. So we talked about using that graph. If it's a 2 by 3, there's going to be 6 cells. And then we're going to split the data into those 6 cells and then look at the normality for each of the individual cells. We're going to look at the outliers, splitting each of the individual cells, and also do that with homogeneity of variance, compare the variance of the largest cell with the cell with the smallest variance. So that's the only difference, and these are the 4 assumptions. So part of this will be a review for the one-way ANOVA. One is normality, one is independence of error, homogeneity of variance, and absence of the outlier. And then for normality, we have different ways of looking at it. I would say start with Tabachnik and Fidel. If it meets these 4 criterions, it's robust. So we don't even need to bother to check the skewness and kurtosis. But if it doesn't, we can look to see if the kurtosis skewness is extreme or not. And we could use the -2, +2 Larson 2013 as a way to, a guideline. Independence of error, that's related to design, so we won't be testing this in our homework or assignments. Homogeneity of variance, we talked about this. We can use Fmax. And then if it meets these 3 criteria, we can use the 10-to-1 lenient ratio. If not, we can see if it's within the 3-to-1 or 4-to-1. And another alternative, which is a little bit more sensitive, is using the Levine's test. And then the last part is to test for extreme outliers. And so we look at z-scores. If it has the degrees of freedom is over 20, and then the criterion would be 3.3. If it's less than 20, it's 2.58.